Hi everyone. Now we are going to discuss about trick for hybridization in organic compounds. Right. Here between two carbon atoms only single bond is present. There is a sigma bond. There is no pi bonds. Then that carbon atom undergoes sp3 hybridization and it have tetrahedral geometry and the bond angle is 109 degrees 28 minutes and carbon-carbon bond length is 1.54 angstroms and it is found in alkane molecules like methane and ethane, etc. Right. Next, between two carbon atoms, two bonds are present. One is a sigma bond, other one is a pi bond. Then that carbon atom undergoes sp2 hybridization and it have trigonal planar geometry, or simply we call it as planar geometry, trigonal planar or planar geometry, right? And here the bond angle is 120 degrees and carbon-carbon bond length is 1.34 angstroms and it is found in alkene molecules like C2H4, there is ethene, C3H6, propene, this are all etc. Right? Okay. Next one. Between two carbon atoms, three bonds are present. Triple bond is present. Among that, one is sigma bond. Remaining two are pi bonds. Okay, totally three bonds. Triple bond is present. And the carbon undergoes sp hybridization and it have linear geometry, that is SPL, okay, that is your class teacher special like that, sp hybridization, linear geometry, and then the bond angle is 180 degrees and carbon-carbon bond length 1.24 angstroms and it is found in alkyne molecules, and there is C2H2, ethyl and C3H4 propyne like this, right? And also we can found in functional groups also. For example, a carbon oxygen double bond is there. There is carbonyl compounds in this and ketone. There is aldehydes and ketones and carboxylic acid COOH and acid amides CONH2. Okay, and acid halides COX. In all these, the carbon atom undergoes sp2 hybridization because here this carbon 1, 2, 3 sigma bonds, one pi bond is present. If one pi bond is present, then the pi bond is 1. Then that carbon undergoes sp2 hybridization. Okay, here one pi bond is present. Okay, next one. If between the carbon and nitrogen, three bonds are these are cyanides and isocyanides in these compounds, or maybe between the nitrogen, but we are discussing about organic compounds. Here carbon nitrogen triple bond is present, so that's why this carbon atom undergoes sp hybridization. Okay, so for example, this is they frame the question like this. So in this middle carbon, central carbon undergoes what type of hybridization? Here generally students are committing mistake. So there is a double bond is there. So that's why it is sp2. No, wrong. That is here. So you have to check it here. This carbon having sigma bond, pi bond. This side sigma bond, pi bond. So two pi bonds are present. Then the carbon undergoes sp2 hybridization. Here two pi bonds are present. This carbon. So that's why this carbon undergoes sp hybridization. It is a sp hybridized carbon, but this carbon is right here. This carbon undergoes sp2 because only one pi bond is present in this carbon, and this carbon also is there. This is also one pi bond is present. It is also undergoes sp2 hybridization. Okay, yeah. So this one is okay. This one is okay. Yeah, this carbon. So this carbon is okay. So just represent here. So this central atom, this central carbon undergoes sp hybridization and this carbon undergoes sp2 because one pi bond is there. This carbon also undergoes sp2 hybridization. Okay, is it clear? Is it clear? Right. And next, for example, they will frame the questions like this. Aromatic compounds also. Okay. So in this, here double bond is there and here double bond is there. Okay. And so this compound, or maybe here there is you can represent it is a carbon oxygen or double bond is present, right? So then this carbon undergoes sp2. This is also sp2 because here one pi bond is present. This carbon having one pi bond. This carbon also having one pi bond. Okay, so this is a pi bond, right? So sp2, and here all are sigma bonds. No pi bond. 0. Pi bond is 0. Then that is sp3. Here no pi bonds. So that's why it is a sp3. Yeah, and this is here this carbon having one pi bond is present. So that's why it undergoes sp2. And here no pi bonds. No pi bond means sp3. Okay, and this carbon here, this is no pi bonds. So that's why it is also undergoes sp3. Okay, and next another carbon, this one here carbon oxygen here sigma 1 sigma 1 sigma 1. This is sigma sigma sigma, but this is one pi bond is present. That's why this carbon undergoes sp2. And here this carbon having one pi bond is present, so it undergoes sp2. Okay, and this carbon here no pi bond, all are sigma bond, it undergoes sp3. Okay, is it clear? So this is the way you have to find out the type of hybridization. Yeah, so thanks for watching my video. Okay.